Today's lesson is about light for artists. And even if you are drawing in a very stylized way, understanding light is still important because that stylization is still based on reality. Let's start with emissive materials. What are some light sources? Well, our light sources are, for example, the sun, but also a lamp and something that is very hot. The way we see things is that a light source is casting rays of light to an object, and this is the surface of that object, and it bounces off of it into our eyes. That is how we see the world. And to better understand why things look the way they do, it's important to understand light and to imagine what is happening with that light. And here's an example of the roughness of a material. This surface is very smooth, but this surface is all rough. And you can see that the light rays, they bounce into all directions. What does that mean? This means that in here you can see the reflection of an object the way it is. You can see it like it is a mirror. But in here the light is all over the place. Let's take a look at what this looks like exactly. Here's a diffuse material with roughness increasing. So this is very low roughness. The surface is very flat, and here the surface is much more rough. And you can imagine touching a surface and imagine if it's feeling rough or not to know how reflective it is. A lot of materials are diffuse, such as wood or stone, but also a material like plastic. Wood and stone, you can see they are quite rough. There's a highlight over here, it's brighter there, and I would say it's comparable to this amount of roughness. Plastic can be very smooth because it's cast, so plastic can be quite reflective, like this. And the rougher part of this plastic, like this area here, will of course be less reflective. So moving on from diffusion, we have reflection. This is something that metals have. Now, you can also say that this surface is reflecting light, but these are specifically reflective materials, which are the metals. And you can see here a low roughness gives us a mirror, and a higher roughness gives us a material with a more blurred highlight. And here's an example of a surface that is rougher and therefore less reflective, because it's more like this. And so far this might be quite simple, but in this lesson we will be moving to more advanced topics, so don't be afraid. And if you already have questions, you can ask those in the No Mic channel, and don't be afraid to ping me. So we've had diffuse and reflective materials. Let's move on to refractive materials. This is, for example, glass or water. You can see here that the area behind it is warped and it is inverted, it's upside down. And as it gets rougher, it is more blurry. And one important property to think about with refractive materials is that they are also reflective virtually all of the time. You can see through water and through glass, you can look at what's behind it, but you can also see yourself in it. I hope that answers your question. I'll be moving on to the refractive materials. Glass and water, you can see what's behind it, but you can also see your reflection in it. So refractive materials, they are also reflective, and that's called dielectrics. It's not exactly the same thing as in physics dielectrics, but that's what they're called in graphics. Now here you can see an example of frosted glass with a rougher surface. So what's behind it is more blurred and you can see your reflection in it very clearly. So those were diffuse, reflective and refractive materials, which are kind of the material properties of surfaces. If there are any questions about those. it doesn't bounce the light off. Well, it does too because of reflection, but it also lets the light pass through at a different angle. Somebody posted a great picture of it. Here is what someone posted in Discord. And this angle is actually different for different materials. For example, diamonds have a very large index of refraction. The index of refraction is how this bounces, at what angle it goes through. So diamonds, they look very pretty because in its surface, light isn't just going through like that. It's going all over the place, and you get a lot of reflections in it. Diamond has a lot higher index of refraction than, for example, glass or water. But then those were the refractive materials. A nice reminder of the physics lessons back in high school, if you have had those already. If there are any other questions, I'll just go back to this topic later, because I'll be moving on to volumes right now. Over here, we have volumes. Let's look at this. Volume scattering. Surfaces are not the only thing that can bounce light. But light can also bounce inside of a volume against particles inside of this volume. Smoke or fog, the light is coming in here and it can bounce off of something into our eyes. Of course, it also always bounces. It bounces all over the place, but the rays that reach our eye are the important ones because those we see. So with particles in the air, we can see these. These are called God rays. And that is how light can bounce in a volume. Another form of scattering, and it's called scattering because it is scattering the light all over the place, which is how we can see a volume. Another type of scattering is subsurface scattering. Now this is quite advanced, but you might have already heard of it because it's very important for drawing skin. Here there's a flashlight behind it. You can see the red in here very well. Here there will be a flashlight behind it, and the entire hand glows up in red. Because subsurface scattering, what does it look like? This is a surface again, but it kind of behaves like a volume because it's scattering, so I included it here. Let's draw the surface. The light is coming in here, and it actually bounces inside of it a few times and then can bounce back out again. And it can do this on this side or on the other side. That is why you can look through an air. So this is subsurface scattering, and it's very realistic to draw skin realistically, because this is what makes it feel fleshy and soft. A lot of organic materials have this, and also marble for some reason, but that's not very important. So what you're seeing right here is that the light bounces inside a few times and then leaves. And as you might see, it's quite red. That is because inside you and I are red, our blood. And here light is coming from the back through it, but it can also bounce a little bit and out again. Maybe you've ever heard, maybe a YouTube artist has once told you to draw where a shadow ends on the skin and where light begins, to add a little bit of reddish color there. And that's because of this. Let's draw the skin. This is the skin, so this is inside the skin. And let's say the light is coming from here. That means over here there's a shadow, right? So here there's an area. Will be a soft shadow because the surface is curving away from us. This is where there will be shadow here and light here. And subsurface scattering, it can bounce around a little bit in here and jump out, but well, we won't really notice it that strongly because there's also just light bouncing away from it. But here on the shadow, this part which is in shadow, there's actually a small area here where light can touch the surface, where light can reach, bounce inside a little bit, and leave on the part that is inside of the shadow. And this is why at the edge of where the light is, where the shadow begins, it will be a little bit more reddish for a small part. And I'll jump over to a simpler one, a volume absorption. A little bit of water is clear, but the ocean is blue. This is because over a volume, the volume can absorb the light, and the amount of light will decrease, and it will become more and more of the color that this volume is. And now we are speaking about water as a volume. Of course, it also has a surface, water, and in here light can bounce off, reflective, or bounce through, refractive. But now about the volume. This is a very saturated blue. You can see how much to the side it is. And this, well, the light and color is not really in scope for these lessons, but that's why I might do a second lesson. And this is why a little bit of water can be clear, but over an enormous amount of volume, this light gets absorbed. Same for the sky. This is why the sky is blue. Now, a quick note to wrap up our chapter of surfaces. Let's look at this material. This is a car. You can see a massive highlight over here. This is the highlight. And if we look at the metals, well, it kind of looks like this roughness. But hey, we have very low roughness reflections, like it's a mirror as well. Look at those. So there's a rough highlight, but these highlights, they are not rough at all. This is because this car, this metal, has a clear coat. That is a second material with a different roughness. So the metal has this as its highlight. And this is the highlight of the clear coat. And the clear coat, it will be reflective and refractive. The refractive part doesn't really matter here because it's right on a surface. But the reflective part, that does. A coating is a different material added onto it. Here, skin. This skin is wet. And if we look over here, this is a very rough surface. And if your skin gets wet, it gets more reflective, right? But it's not like the skin itself gets more reflective. It's just that there's water droplets on there that are reflective. So now we have the skin in beneath and water over here, which is reflective. That's how, again, two materials are combined. And here we have an eye, so that's quite complex. We have a material over here, the iris, but we also have a reflection over here. And that's because, well, the eye is wet, so that's a material on there. And over here you can see that this looks quite fleshy, this is quite red, and that's again because of subsurface scattering. Light's coming in from here, and maybe this part is a little bit in shadow, but it can bounce around a little bit. So the eye is an example of so many materials coming together, and there's hairs, there's so much going on. So that was just to make you aware that, for example, a clear coat is actually a second material with another type of highlight and another roughness. So now we've done this entire part already. And we are about halfway through now. You've now all had an in-depth explanation of materials, about surfaces and about volumes. But now let's look at light itself, how light interacts with surfaces. Because this behavior, it also adds a lot of realism. Okay, here we have ambient occlusion. So now we're going to talk about how light itself bounces, separated from materials. This is called ambient occlusion. On the left there's no ambient occlusion, and here we have ambient occlusion. You can see that that places where objects are close to each other are darker. And it adds a lot of realism. This looks realistic. This doesn't really. There are no hard shadows here. There's just ambient occlusion. This is because if light bounces on here, it's quite likely to reach your eye. But if light gets inside of one of these corners, it will bounce around a little bit and it's just less likely to still reach your eye. Light in corners, you can imagine it getting stuck. Let's look at this image. There's no real defined shadow, there's only ambient occlusion. Light is coming from all directions here. That's a very ugly arrow. Okay, and we can see here, the reason we can see these shapes is because where they are touching each other, they get darker. Over here too, you can see this, it gets darker over here. In these corners, you can look around in your room right now and look at the corner of a wall. It's very hard to see because our eyes, we look at color and value kind of relatively. But if you try to analyze it very hard, then you'll see that the corners of your room, they are darker. Light in here, it can still reach your eye just fine, but it is less likely to get in a corner and still reach your eye. And you can see ambient occlusion below this desk. It is the most extreme. Light comes here, it can bounce all over the place, and it is less likely to still get out. So that's ambient occlusion. Now if we look over here, we can see clearly a shadow. This is the shadow. Okay, the shadow is here and this is the ambient occlusion. It's much darker than the shadow actually. And why is that? Well, if light couldn't bounce, if light only reached here, then our shadow would be perfectly pitch black. But in here there's still a lot of light. We can see the shadow clearly, so there's still light coming in the shadow. If we look at it, the floor is white, right? But look at how green this shadow is. This is the white floor. It's entirely green. This is because light is bouncing on this ball, it reaches the shadow, and then it can reach our eye. And light is less likely to bounce against the wall. Light can't bounce directly to the shadow at all because the object is in the way. But light is less likely to bounce on the wall, somehow bounce in here, and then still reach our eye. So the ambient occlusion here, it still applies, and it's really dark here. But here, our shadow is colored green because light has bounced against the wall, it has become green light, and it reaches our shadow. We can also look at the light of the ball. Look at this, the white ball is green here too, because of light bouncing against the wall and against the ball. And here, this part of the ball is red, because of this red wall. This is ambient lighting. Here, the white floor is colored red. Ambient lighting in video games is called global illumination, and that's quite a cool technique. You can see here the green carpet is coloring this wall green, and here it's red. Now I have something important to say, something that you might have been taught wrong by virtually all artists on YouTube. A warm light does not create cold shadows, and a cold light does not create warm shadows. I hear this from YouTube artists quite frequently. It's not true. I will explain now how this works. You can look at this drawing. You can look, this is a warm light. This is from the sun. I hear the opposite more frequent. So do you mean that you hear artists saying a warm light creates cold shadow? Or, yeah, right, that's what you hear, right? Yeah, indeed. And that is also what I hear a lot, and it's wrong. And I'll now explain why. This is just a big misconception, really, that I wanted to include in here. Well, we're talking about it anyway. Here, we have a warm light from the sun. The sun, it is warm, of course. And this is a cold shadow. This blue, where is it coming from? Is it created by the warm sunlight? No, that's just because the sky is blue. The sky, you can see it, so photons from it are reaching your eye, so that's blue light coming from the sky. And that is what we talked about in here, volume scattering and volume absorption. The sky, light is getting to the sky and can be bounced off the sky, so we see the sky, otherwise it would be black, we would just see space. And we get warm light like this, direct sunlight. So we get cold light from the sky and warm light from our sun. The ambient lighting is blue. Here it's green and here it's red. This is why drawing shadows in blue, it looks very natural. We see that all the time, except when it's really cloudy and the sky is gray. But the sun being warm does not magically create cool shadows, and a cool light does not magically create warm shadows. If you close your room, there's no light in your room anymore, and you light a candle, then if you look at the light from the candle, that's warm light. And let's say your room is white, like the walls are not blue, because then it would be a blue ambient light. But let's say your room is white, you light a candle in there. The light will be warm from the candle, but so will the shadows, because those are just bounced candle light. I think if you watch a lot of art videos, you have heard artists say warm light creates cold shadows, cold light creates warm shadows. That's not true, but it does look very natural, because in our lives we see it all the time. We see a warm light and a cold shadow. That's because of other things. The ambient light, the sky, or a blue wall. And it's also a matter of contrast. Artistically, it makes sense. Moving on of ambient light. A lot about ambient light and ambient occlusion here. Let's go to the last subject. Fresnel. What is Fresnel? Let's look at this cup. It's not very reflective here, right? We don't see the camera or the face of a person in this reflection. But then we look over here. Wow, it is super reflective, this material. It's a mirror on the side. We can see the wood in this reflection over here. This is because on the sides of an object, the object gets more reflective. If you bounce over here, and it's a diffuse color with it's a diffuse material with some roughness, it can bounce right there. It can bounce over there. Like it can bounce all over the place, and it's not a clear reflection like this, like a mirror. But on a very high angle, if the light is coming from an extreme angle like this, it will leave that object in a similar angle. The spread of roughness that you see, it's mostly there when the light is coming from that direction. At a very high angle like this, the light will bounce off in a similar angle, and it is more reflective. Here on the side of our cup, it gets more reflective because of Fresnel. If the object is facing away from us a lot, like over here, and over here too, this is a surface that we are looking at, like from the side, if this is a 3D plane. So on the side, objects get more reflective, and in fact that's fantastic for backlight, which is artistically pretty cool. And everything has Fresnel. Cardboard and stone, they have Fresnel too. You might not think about them as reflective objects, but they do get a little bit more reflective from extreme angles. So if you look at, for example, your door or some wood, some cardboard, look at it from the front, not very reflective, you can see the environment in there. Look at it from an angle as extreme as possible, and it gets more reflective. You can kind of see the color of whatever is over there. Fresnel and most importantly ambient occlusion, doing these properly will make it will level up your drawing. And if you are drawing in a stylized manner, it's still important, I think, to understand how the world and light works. We've now talked about all this theory. There's only a little bit more that I want to talk about for a short time. Ocean as Fresnel, yeah, that's very important. It's very noticeable in water, indeed. Let's take a look at this. Over here, you can see the color of the ocean, and as it gets more to the surface, it actually gets brighter, more reflective. And in this image too, the higher the angle here, it becomes brighter over that extreme angle. Then I'll move on to the last subject of the presentation, and that is that in preparation for this art class, I've rendered a few examples. I didn't draw these. These are 3D rendered, but I did draw these. So to study how this lighting behaves, these are the renders and these are my drawings. To study how the light works, to get a feeling for ambient occlusion and for shadows and bounce light, I drew these because I think that's you now theoretically understand all of this, but how much ambient occlusion do you actually have? Is it still dark over here? To really study that, you should just draw it, of course. And I think a 3D render is better for this than a real-life picture, because in a 3D render you have complete control over the environment. There's no complex light from other objects around here reaching it. You can just look at ambient occlusion itself without interference from all kinds of things. You don't get a controlled environment like this in real life. But to draw the real world, you will have to move on to drawing real pictures, of course. But to get a feeling for these properties of materials, I think this is a great drawing exercise. And studying with a color picker, because it's hard to look at an object and to say what color it is exactly. This part, is that brighter than this part, or which one is brighter? It's hard to look at because we see color and things relatively. So observe with a color picker. That's a great idea. To just say, well, which part is actually darker? Which part is lighter? What's the darkest part of a shadow? What's the lightest part of a shadow? It's hard to tell, so look at it with a color picker. And that's how I did this, by looking at, well, okay, it gets brighter here. And this is how the color changes over here. Well, something that you'll learn from this, for example, is this color here, the floor. Light is coming in here, and it can then bounce into your eye. That's why it has this color. Now let's look at the color picker. Let's look at this part. Let's look at what happens. Wow, it just got a lot brighter. But there's no other light source. The light is coming from here. That's the amount of light that determines this, the shade of this. But it got brighter here. Look at how much brighter that is. Why is that? I'll let you think about it for a second. While I take a sip of my iced tea. Over here, we get this amount of light from our light source. Over here, there's no shadow here yet, so we also get that amount. But somehow more light reaches this place as we get closer to the sphere. And this is also visible in other drawings. Like, look at this, and then bang, brighter, much brighter. What's happening here is that here it gets this amount of light. Here it also gets this amount of light, but also here. More light is able to reach here because it's not just the direct light from our light source. We can get bounce light over here. You can get the normal amount of light that also gets over here, plus some bounce light. That is why, closer to this object, it gets brighter. So this is funny because we are getting closer to the object and it gets brighter. What did we learn here? Well, we get closer to an object and it gets darker. This is called bounce light, this light. But here we still also have ambient occlusion. So here there's an area where we get more light because light can bounce. And here there's an area where we get less light because light is less likely to get in here and still reach us. It will just get stuck. So our shadow can also have a brightest spot because light can bounce in there, just like it does here. Very green, much brighter than here. Light won't get into this ball and then get over here. So this is probably the brightest part of the shadow. And I hope you can look around to the world, look at the world around you and think about this color on your wall. Where's that coming from? Oh, well, one more thing. Yeah. So over here, this is how I made these renders. I'm not in front of my keyboard right now. Yeah, Blender. So I just changed the roughness of a sphere around. And then I switched between a metallic and a diffuse material. I didn't make any refractive ones myself. You can see it's now kind of reflective, like plastic. And I picked some of the different standard Blender environment lights. And you can, of course, download your own. And I don't think you need a lot of Blender skills to make your own study material for light. And the reason I think this is better than pictures is because there's not a lot going on in this picture. It's easy to understand. It's really simple because you have perfect control about it in this 3D environment. Is it okay to use Eevee for that? I wouldn't really. I would definitely recommend Cycles because Eevee, it does ambient occlusion as a trick. It's not how it's not entirely correct. It's just like video games. While Cycles is a ray tracer, it's actually tracing the rays, and this is correct light. You can see here that it gets brighter over here. You don't get this effect in Eevee, this bounce light, where this surface gets brighter here. So definitely Cycles. This was today's lesson, really. I've talked about all the content that I wanted today. So I think that from now on, I'll just be answering questions and explaining things that somebody didn't understand the amount they wanted to yet.